functions. In this tutorial, we are going to go over the basics of functions. Function, I can say function is just like simple motion. Function is a motion that makes mathematics a lot easier. Okay, it is a machine on a paper. Okay, this is just informal way of explaining or defining functions. So just like any machine, it has input. We have input and we have output. Okay, it's good to visualize machine function as a machine. So there is a process here when we specify a function outside mathematics is just to mean what something does. Function means what something does, but in mathematics we have very specific meaning for functions. Okay, a function is it's connect function connect. Okay, it's connect or relate. It's good to use a relation. It's a special type of relation. It relates two sets. Okay, it relates one set to another. One set, set is a collection of well-defined objects. Okay, one set to another. It's good to see it this way. Okay, so we have, which means we have two sets. Okay, we have the input set here and the output sets. Okay, so a function specifically, there is a process here, of course. Maybe that could be addition or subtraction, multiplication or division. Maybe you're asked to square it to the nth power. Maybe you have to put it under the square root, or maybe you have to whatever mathematical or maybe integrate and so on and so on. So we have a different ways to process here. The processing is, of course, is different. Okay, so the process is here. So every function, every machine has a purpose. So does a function. Every function has a purpose. In this case, it's restrict to a very specific amount of inputs. Okay, that's what makes it its a special relation. Okay, so let's see this with example. Okay, let's see this example. For example, let's use maybe here different function. Let's use the input. Okay, we have input here. Okay, we have input here, and we have let it be, this is the rules or processing, or maybe rules or just as processing, and we have output. Okay, let's see with specific examples. Let's have a line here. Okay, to make it very clear. Okay, so it's kind of good. So now let's take one of the expression here. Maybe this machine is putting whatever. Let's represent the input as x. Okay, we can represent the input as x. So whatever the input, maybe it squares it and add one more. Okay, so in this case, maybe the input could be natural number. Okay, it could be a natural number. If you put any natural number like 1, 2, and 3, or let's say the output will become, for example, if you put a 1, that goes to 2. If you put 2 square 4 plus 1 is 5, and 3, 9 plus 1 is 10. So as you can see, the input or our first set is the set of natural number. Okay, so the output, as you can see, of course, it's difficult to say something the name, but it's another set of numbers. another set of numbers, but still it's part of natural number. Okay, let's see another function, okay, where the input is a bit different. Let it be sine x, okay, sine x. In this case, our input could be the angles, okay, 60°, 90°, and so on. So whenever, as you can see, I just change the set. Okay, the first set is now is a degree. So sine 60 is I think √3/2, and sine 90 is 1, and so on. So the input here is just degree, and the output is set of real numbers. Okay, so let's see another example. Let it be piece by piece, or two functions. Maybe let it be that is x squared for x greater than maybe 1, and let it be x minus 1 if x is less than or equals to 1. So in this case, this is a bit different. Okay, even though we may have a different set of inputs, but we have two functions that depends on the values of x. Okay, so for example, if I put any value, let it be -2. Okay, -2 is less than 0, so we have to use the second equation. Okay, which means -2 minus 1 is -3. Okay, if I have -1, still -1 minus 1 is just -2, and so let's plug in, maybe even if you include 0, of course, which means this is kind of telling me that state of integer. So if you put it 0, 0 is still here in the second equation, that goes to -1. Okay, so if I have, for example, 4 is greater than or equals to 1, therefore 4 squared is 16, and so on and so on. So if I have 5 squared 25. So you see, you have another set of integers. So in this case, the input, or the first set, is connected to the second set by these two. These two are connected. Let me use maybe this one. Okay, these two are connected. Okay, this is the functions. Okay, the function connects two sets, or it relates two sets. Okay, there you have function. Okay, therefore, what makes a function different from a relation is that this is the key. For every input, this is for every the first set. For every first set or input, there is exactly one output. This is the key. This is the key for functions. So let's define in this way. A function is a relation. Okay, let's put it here. Okay, a function is a relation, a special relation, or a relation. Okay, a relation between. Okay, between two sets. Okay, but there is two sets of numbers. Two sets of numbers, such that, okay, this is a key, such that for each value of, for each value of input, or the first set, or we call here in this case the domain. In the domain, okay, in the domain, which is the first state, in the domain, there is only, okay, there is only, okay, just only one corresponding, okay, let me write here, okay, one corresponding, okay, corresponding value in the range, okay, value in the range. Okay, so the second set, this is called range, which is the output, and the first set is called domain. Okay, so for every domain, there has to be only one range, which means it doesn't matter for the second coordinate. We may have the second two range values, but we can't have two domain value, which means one domain or one value of x always paired with one value of y. Okay, but if you're using, for example, in a set situation, okay, we can't have double value. Okay, or let's visualize this using Venn diagram. Okay, if this is a Venn diagram, if you have this is x, which is the input, and y, which is the output, if these two are related by a function f, so as you can see, we have, for example, in this case, we have every value. Okay, every value of x need to have one value of y. Okay, this is just an example. We can't pair, or if you consider this as for example object, okay, and if you consider this as image, for every object there has to be only one object, I mean one image. For every object there has to be one image. Okay, so we can't have we can't have two image for one object. Okay, that's the essence, that's the main point of a function. That's what makes it different from our special relation. In case of relation, it doesn't matter. What we need is the order pair. But in case of function, every first set or domain has only single value of the output or range. Okay, for example, and if we consider one of the coffee grinding machine, the input is coffee and the output is coffee powder, right? We can't have juice unless that specific machine has a dual purpose. Okay, so every function has a purpose, which means in this case we can consider that as a domain. So specifications. Of course, there are machines that works more than or multifunctions, but if you consider only one of the machine, okay, in this case, these are good examples. Okay, these are good examples for machines. So this is the main point. Next time we'll see the forms or types of functions and then how to represent functions. Just watch the next videos.